Welcome back to the deep dive. You know, for years now, when we thought AI, we pretty much pictured these huge cloud-based systems, right?
Absolutely. If you wanted anything smart, translation, generating text, whatever, you were tapping into these massive, expensive data centers somewhere far away.
Yeah, far away and often costly.
And that whole setup, well, it came with a built-in set of problems that, frankly, users and developers just had to live with.
What kind of problems are we talking about?
Well, major ones, really.
Sure.
Big data privacy worries because, your stuff, your input might have to be sent off your device.
Right.
Then there's the network lag, the latency, that constant back and forth communication slowing things down, and, of course, the cost. Those operating expenses could get really high, especially if you needed to use AI a lot.
Okay, let's unpack this a bit, because what we're discussing today feels like a really fundamental shift, like a seismic shift in how AI works.
It really is.
We're moving beyond this idea that AI has to be gigantic, general purpose, and stuck in the cloud. We're heading towards something defined much more by, well, local processing, keeping your data truly private and making it way more accessible.
Yeah.
So today we're diving deep into micro-language models, these micro-LMs, and this Web4 AI architecture that's really pushing this serverless idea.
And our mission today is laser-focused. We want to really analyze this specific model, the LSW4-270M Micro T1 from Web4 AI.
Okay.
Because it's kind of the perfect example of this whole Web4 approach. We need to dig past the marketing buzzwords and really understand the nuts and bolts.
Understand how it works?
Yeah. How does this serverless thing actually solve those big old cloud problems, the privacy risks, the lag, the high costs?
So think of this deep dive, listener, as your shortcut, your way to really grasp what it means to have AI performance that's truly yours, truly sovereign. We mean sophisticated AI running right there on your own device, completely untethered from that centralized cloud infrastructure that's dominated everything until now.
And that shift, it changes the basic economics, the security equation, everything about AI.
It's not just a small improvement then.
Oh, not at all. This isn't just making things a tiny bit more efficient. It's a complete rethink. A rethink of where AI should run and how it should work.
Driven by
real needs, the need for much better data protection, and the need for applications that just feel faster, more responsive.
Okay, so this brings us into this new era, micro-LMs. Sovereign performance, you said, but in a compact form. It feels like this isn't just a cool trend. It sounds like it's almost necessary, right?
Physics.
Privacy.
Precisely. The era where these giant LLMs grabbed all the headlines, needing billions of parameters, months of training, huge amounts of power constantly. That's starting to change.
Yeah.
We're finally seeing a much more varied, more specialized approach emerging.
And that specialization, that variety, that's what we're calling AI democratization.
That's the idea.
And these micro-LMs are sort of the leading edge of that.
You could say that, yeah. While the huge LLMs try to know a little bit about everything like an encyclopedia, but maybe not super deep on any one thing.
Right, generalists.
Exactly. Micro-LMs are different. They are all about efficiency, being really good at one specific thing and running locally, right where you are.
So they trade that massive breadth for real depth in one area.
Precisely. They give up knowing everything to be world-class experts in a single domain.
How do they manage that? To be expert but small?
Well, it's an efficiency game. A model with, say, 70 billion parameters is incredibly powerful, no doubt. But it's kind of overkill, maybe even wasteful, if all you need it for is one specific, repeatable task.
Okay.
These micro-LMs, on the other hand, they're carefully built, meticulously trained to give you that expert knowledge in one area, but with a really, really tiny footprint computationally.
And how do engineers achieve that small footprint? There must be specific techniques.
Oh, definitely. A big one is quantization. That's a key technique.
Quantization. What does that involve, practically speaking?
It means reducing the numerical precision of the model's parameters, the weights. So instead of using, say, standard 32-bit floating point numbers, they might crunch them down to 8-bit integers, or sometimes even 4-bit.
And reducing the precision like that, it doesn't hurt the performance too much?
There's a trade-off, always. But the goal is to find the sweet spot. And the benefit is huge.
How so?
Well, cutting down that precision doesn't just shrink the physical size of the model file, which is great for storage. It also dramatically speeds up how fast the model can make predictions, the inference time.
Ah.
And it needs less memory bandwidth to run. So suddenly, you can put powerful AI onto literally billions of devices out there, phones, tablets, laptops, things with limited memory and processing power.
Not just the giant server farm.
Exactly. It brings AI out of the data center and onto the devices people actually use every day.
And leading this charge, this specialized approach, is the model we're focusing on today.
That's right. The pioneer we're digging into,
Yeah.
the LSW4-270M Micro T1.
Okay, now I want to push back a bit here because when people hear micro LM, I think many assume it's just, a smaller, maybe dumber version of a big LLM.
That's a common misconception, yeah.
But you're saying this one is different. It's a precisely crafted, specialized AI agent. What makes its design philosophy so distinct from just shrinking a big model?
It's the core intent behind it. The whole design philosophy is laser focused on efficiency and accuracy for a very specific job.
Okay.
It's built from the ground up to be deployed right at the network edge, literally on your phone, your tablet, your computer.
Right there with the user.
Exactly. The goal isn't just make it smaller, it's maximize the performance you get for every watt of power used and for every parameter in the model.
Performance per watt, performance per parameter, that's a different metric.
It is, and it's designed as a localized service, which is why it fits into Web4 AI's W4LS series. The LS stands for localized services.
And the capability it delivers, which we'll get into, it sounds like it's pretty impressive, especially considering its size.
It really is. It brings sophisticated abilities, things that used to require those expensive data centers, right to your device.
Now with essentially zero delay.
Zero network latency. Yeah.
And complete privacy.
Exactly. It's the tangible result of Web4 AI's focus on localized intelligence. It's engineered specifically to tackle those pain points we mentioned earlier, the data risks, the network lag, the cloud infrastructure costs.
Okay, let's get into the weeds then, because achieving that kind of performance in something so small and efficient, that takes some serious engineering. Let's dive deep into the architecture and performance of this LSW4-270M Micro T1.
Right. So when you look under the hood, it really is a masterpiece of specialized efficiency. Web4 AI didn't try to reinvent everything from scratch.
Sure.
They built on a really solid, well-respected foundation. That helps reduce the risks in training and gives you a good starting point for quality.
And that foundation is Google's Gemma architecture, specifically Gemma 3270M.
That's the one. And choosing that base, Gemma 3270M, it's very deliberate.
Why Gemma? What does that bring?
Well, building on that foundation gives you a trustworthy, ethically sound base right from the start. You inherit the careful training, the safety measures that went into a model designed for responsible use.
Okay, so it's got good bones, so to speak.
Exactly. And the Gemma family is actually known for running pretty well on consumer-level hardware, which makes it a great starting point if you're building an agent designed for local use.
But Web4 AI didn't just take it off the shelf, right? They innovated on top of it.
Precisely. And here's where it gets interesting with the parameters. The spec says 2 times 270 million parameters, totaling 540 million. It's not just a flat 540M.
Wait, $2 times 270 others, that sounds specific. Why structure it like that? For listeners, what's the difference between that and just a single 540 million parameter model? Why is $2 times 270 MLAT potentially better here?
It strongly suggests some kind of smart architecture, maybe selective activation or possibly a sparse setup, kind of like a simplified version of what's called a mixture of experts or MOE.
Mixture of experts. Okay, break that down.
In basic terms, instead of firing up all 540 million parameters every single time you ask it something.
Which would use more power and time.
Right. The system might intelligently route your request to just one of the 270 million parameter experts, or maybe a specific combination of them that's best suited for that particular query.
Ah, so it's like having two specialized mini brains inside. And the system picks the right one or the right bits of each for the job.
Something like that, yes.
So you get the power of a larger model, but you only activate what you need at any given moment, keeping the active computation and memory use down.
Exactly. That sounds brilliant for running on something like a phone or laptop with limited resources.
It's clever engineering. It means you get significant generative ability packed into this minimalist design.
It's small enough to be portable, to run instantly, but that specialized architecture ensures it's still really smart within a specific area.
Okay, let's define that area then. This is where that laser-focused specialization you mentioned comes in. What is this model actually designed to do, and why is being specialized better for that task?
The focus is absolutely key. This model isn't designed as a typical causal language model, or CLM.
Which is what most of the big ones are, right? Like GPT-4, generating text sequentially.
Exactly. Those generate text word by word, predicting the next word based on what came before. This micro-LM, however, is designed as a masked language model, an MLM.
MLM. Okay, that's a critical difference technically. What does that mean in practice? How does an MLM work differently from a CLM for the user?
It's about how they understand context. CLMs are great for generating flowing text like writing an article. MLMs, though, are trained differently. They learn to understand context from both sides before and after a word.
Bidirectionally.
Yes. So they excel at tasks like filling in missing words in a sentence, refining existing text, and really grasping the overall structure and meaning of the entire input, not just the words that came before.
Okay, so for what kind of task is that MLM approach better?
Well, think about tasks where you need a deep understanding of the whole context to produce something very specific and refined. Like analyzing a photo you just took, understanding the prompt you gave it, maybe the mood or style you want, and then generating a really specific, clever caption for it.
Okay. The caption needs to fit the whole picture in the prompt, not just flow like a story.
Precisely. For that kind of task, the MLM architecture is inherently better suited. It can look at all the pieces, the image data, the desired tone, the context, and output. A highly optimized short piece of text, like a caption.
And to get really good at that specific task, the training was intense. You mentioned the data sets.
Oh yeah, truly rigorous training. It was specialized on over 50,000 data sets.
50,000. That's a huge amount of data, but focused entirely on
the domain of social media communication. Captions, styles, relevant phrasing, engagement tactics. So its primary job, its reason for existing, is the generation of engaging and contextually relevant social media captions.
And the result of all that focused training.
The implication is pretty powerful. That deep specialization means it should deliver superior quality, creativity, and relevance for that specific task. Much better than the often generic kind of bland suggestions you might get from a giant general purpose model trying to do the same thing.
Okay, I can see that.
Yeah.
But let me play devil's advocate. 50,000 specialized data sets is impressive for social media. But does that create a limitation? What if I tried to use this model for something outside that zone? Like generating a caption for a really complex, ironic piece of abstract art, or maybe a deep philosophical quote. Would it just fail? Would a big LLM with access to literature and art history be better then?
That's a fantastic question, and it really cuts to the heart of the specialization trade-off.
Yeah.
And the honest answer is yes, it would likely be constrained. The LSW4 270M Micro T1 would probably do a terrible job writing an essay about abstract art history.
Right.
But that's the point. That's by design. The whole specialization idea means you pick the right tool for the specific job. For the vast majority of social media posts, what do users want? They want quick, relevant, punchy, maybe witty captions. They're not usually aiming for deep philosophical discourse.
True.
So by focusing intensely on those 50,000 data sets related to that common use case, Web4 AI ensures the model absolutely nails its intended function pretty much every time.
So it justifies the minimalist design for that specific high-volume need.
Exactly. It proves that specialization can beat generalization for certain tasks.
And the final piece of this performance picture for the user is speed. You mentioned blazing fast inference speed.
Yes, and this is probably the benefit users will notice most directly, because this micro-LM runs right there on your device's own processor.
Using those optimized NPUs you mentioned, or just the regular CPU?
Either, depending on the device hardware, but it's optimized for both. Because it runs locally, it completely cuts out that network delay.
That round-trip time to send the request to the cloud and get the answer back.
Exactly, that delay is gone.
And even if that delay is only, say, half a second or a second with a cloud model, that makes a huge difference in how an app feels, doesn't it?
It's the difference between feeling seamless and integrated versus feeling like a slightly clunky external tool you have to wait for.
Stop-start experience.
Yeah. When the inference is local, the result feels instantaneous.
So truly, real-time use cases become possible.
Absolutely. Imagine you upload a photo in an app, and bam, the caption suggestions are just there instantly. No waiting, no spinner.
That would be great for posting quickly.
It's crucial for things like social media. It changes AI from being this helpful but sometimes slow assistant you call on to being just a built-in super responsive feature of your device itself.
Okay, architecture, speed. Impressive.
Yeah.
But you said the real revolution is this idea of true serverless operation. How is this fundamentally different and maybe more robust than just being fast?
Right. This is the core innovation, and we need to be really clear what serverless means in this context. It's not the same as serverless cloud computing. Here, it means the LSW4-270M Micro T1 is built exclusively to run entirely locally, either inside a secure web browser environment or directly within an app on the client device.
No central server involved in the thinking part?
None whatsoever for the inference process. The intelligence, the model itself, lives entirely with the user.
But hang on, speed's no good if it's flaky. How do they make sure a complex model like this actually runs reliably? What if I'm deep in the subway with zero signal or traveling abroad with spotty data? How does it work locally without fail?
That's where the deployment packaging comes in. They use these dedicated client-side deployment files.
Okay.
Specifically, the model gets packaged into highly optimized file formats. Often this includes a .task file.
What's that do?
It basically holds the model's metadata information about it and instructions on how to run it. And then there's the main model file itself, often the .tflight file.
Ah, tflight. That sounds like TensorFlow Lite.
Exactly. TensorFlow Lite is Google's framework specifically designed for getting machine learning models to run efficiently on mobile phones, embedded systems, that kind of thing.
So these .tflight files contain the actual model, the weights, the instructions all crunched down?
Yes, all the necessary weights and instructions already quantized and compressed for efficiency. And if it's running in a web browser, it can use technologies like WebAssembly or, even better, the newer WebGPU APIs.
WebGPU, leveraging the graphics card.
Exactly. Using the native processing power of the user's own graphics chip or neural hardware, but all safely contained within the browser's security sandbox.
So the magic is, once you download these relatively small files, the .task and .tflight, your device has everything. It doesn't need to call home to a server during operation.
Precisely. Once it's on a device, it's self-contained, which leads directly to what I think is probably the single biggest advantage for the user.
Let me guess. Maximum data privacy.
You got it. Think about what you feed this model. Your personal photos, maybe context about where you are, prompts about how you're feeling.
Sensitive stuff.
Really sensitive stuff. Now, if you were using a standard cloud LLM, all that data has to leave your device.
Right. Goes over the internet, sits on some company's server.
Subject to their privacy policy, their security measures, the laws where that server is located.
Yeah, a lot of unknowns and potential risks.
But with this model, because the actual processing, the inference, happens locally.
On your phone or laptop.
Your input data, the photos, the context, the prompts, it never leaves your device. It stays right there within the secure confines of your own hardware.
That is fundamentally different.
It's the highest level of security and privacy you can really get today for this kind of task. It's simply not achievable with traditional cloud models that have to see your data remotely to work.
So this serverless approach basically eliminates that whole category of risk data leaks, potential surveillance.
Entirely. And that's not just a feature bullet point. That's a huge psychological shift. You can make people feel much more comfortable using AI for more personal things.
Okay, privacy is huge. What about other global concerns? AI, especially cloud AI, gets a lot of criticism for its environmental footprint, right? The energy consumption.
Yes, and that's another area where this local serverless approach offers a really compelling sustainability benefit.
How so?
Well, just imagine the sheer scale of infrastructure needed to run something like, say, GPT-4 inference for millions of people around the world simultaneously.
Massive server farms.
Huge clusters of powerful GPUs running constantly, 247 in air-conditioned data centers. They draw enormous amounts of electricity.
Leading to significant energy use and CO2 emissions.
Absolutely. Now contrast that with this micro-LM. Where does the computation happen?
On my device. On hardware that's already running anyway, usually a phone chip, right? A system on chip.
Exactly. Often a consumer SOS, which is typically designed with power efficiency heavily in mind.
Because battery life is critical on mobile devices.
Precisely. So, because the heavy lifting, the inference, happens locally on hardware that's increasingly optimized for low power draw, especially with those dedicated NPUs becoming common in phones.
The overall energy used for that specific task gets slashed.
Drastically reduced. Instead of concentrating all that computational demand in a few giant power-hungry data centers, you're distributing the work across billions of much more efficient endpoints.
It's like decentralizing the power consumption for AI tasks.
You could definitely frame it that way. It makes it a much more sustainable, environmentally conscious way to deliver AI. It's intelligence that doesn't demand quite so much from the planet's energy resources.
Okay, so we've got privacy, we've got sustainability. What about the wallet? You mentioned costs earlier.
Yes, the budget angle.
Yeah.
And this is where it gets really practical for users and developers. The advantage is essentially zero operating costs once the model is actually on your device.
Zero. That sounds almost too good to be true compared to cloud AI. How does that work?
Well, think about how cloud AI services usually charge. It's often per token, per query, per inference call.
Right.
Yeah, pay as you go, and it can add up fast, especially for businesses or developers using it heavily.
It really can. But with local processing, that entire cost model disappears.
Yeah.
There are no ongoing cloud inference fees because there's no cloud server doing the work. The meter just isn't running.
So once the app developer integrates the model or the user downloads the app containing it, using the AI feature doesn't cost anything extra per use.
Correct. That is a massive economic shift.
It really opens the door to making sophisticated AI genuinely affordable, truly accessible to everyone, not just companies with big budgets for API calls.
Exactly. It helps move AI from being a premium metered utility to being just an embedded, readily available capability of your software or device.
And the final piece, looping back to reliability, complete offline functionality.
Yes, this tackles that common frustration. You need your smart tool, but you're offline. On a plane, in the subway, maybe just dealing with terrible airport Wi-Fi.
Yeah, happens all the time. Since this model runs entirely using those local files, the .tflight, the .task, it works perfectly fine, reliably, even when you have zero network connection.
The intelligence is always there, always fast, always available because it's right there with you.
Robust, fast, and always on. Regardless of connectivity, it's self-sufficient.
Okay, so this specific model, the LSW4-270M Micro T1, it's a fantastic case study in specialized, efficient, local AI, but it feels like it's part of something bigger. Let's zoom out a bit and talk about Web4 AI itself, the ecosystem they're building.
Absolutely. This micro LM isn't just a one-off product. It's really a demonstration, a testament to Web4 AI's larger vision.
Which is
building a secure, powerful, and accessible AI layer specifically designed for modern digital communities. They're thinking beyond just individual users.
empowering groups, businesses.
Exactly. Empowering them with AI tools they can actually control and trust.
And a key part of that platform you mentioned is foundation data intelligence for these communities. That sounds potentially very powerful, but also complex. How does it work with their privacy-first approach?
It's where the real business value meets that strict privacy guarantee. Web4 AI basically provides the tools and models to let organizations think, like specialized engineering firms, maybe law practices, internal corporate research teams.
Groups with sensitive internal data.
Precisely. It enables them to connect powerful AI agents, like specialized micro-LMs, directly to their own internal on-premise databases.
On-premise meaning the data stays physically within their building on their servers?
Correct. So let's take your example. A lawyer in a small firm, they've got years, maybe decades, of confidential client case files stored securely on their local server network.
Right. Highly sensitive stuff they absolutely cannot upload to a third-party cloud.
Exactly. So how does Web4 AI let them use a smart agent to search or summarize that data without compromising security?
Yeah.
The key is that the AI agent itself, maybe a micro-LM specially trained for legal document analysis or summarization, is deployed locally on the firm's internal network.
The intelligence lives inside their firewall.
Yes, the model is local. Now, when the lawyer asks a question in natural language, like, find all case precedents related to water rights disputes from the 1990s,
Okay.
that query goes to the local AI agent. The agent understands the query and translates it into the specific commands needed to search the firm's local database.
And the actual sensitive case file data, does that get sent to the agent?
No, that's the crucial part. The sensitive data never leaves the firm's on-premise storage. The local database does the search, finds the relevant info, and might return just the necessary summaries or references back to the local agent, which then presents it to the lawyer.
So the agent acts as a smart local interface to the local data.
Exactly. The users get the power of asking questions in plain English and getting real-time insights, but their core sensitive data stays completely secure under their control within their own infrastructure.
That must solve a huge adoption barrier for AI in industries like law, finance, healthcare.
It absolutely does. Anywhere data residency and confidentiality are paramount.
And it seems like this approach is catching on. You mentioned adoption numbers.
The numbers suggest strong validation, yes. The platform is reportedly powering over 22,000 communities already. That indicates real trust in this decentralized, privacy-focused model.
22,000 plus, that's significant buy-in.
And if you look at the developer side, the engagement on platforms like Hugging Face is also impressive. Their models have apparently clocked up over 23 million downloads.
Wow, 23 million downloads on Hugging Face. That suggests developers are actively grabbing these models, experimenting, integrating them. It shows trust from the technical community.
It really does. It indicates widespread interest and acceptance of their underlying architecture and the models they're releasing.
Okay, I have to ask the practical question, though. If the user gets zero operating costs because the inference is local, how does Web4 AI make money? What's the business model if they're not charging per query like the cloud providers?
That's a very fair question. The business model has to shift, right?
Yeah.
It moves away from charging for each transaction, like pay-per token or pay-per inference. Instead, it focuses more on enterprise licensing and providing the foundational tools and platforms.
So selling the picks and shovels, essentially.
Kinda, yeah. They likely generate revenue by providing those highly specialized, optimized base models to businesses. And maybe more importantly, by offering the proprietary platform, the software, the tools that make it easy for these organizations to connect those AI agents securely to their private, on-premise data, that foundation data intelligence layer we talked about.
So they sell the enabling technology, the specialized models, and the integration platform, particularly to businesses who value that privacy and control enough to pay for the setup rather than paying per individual AI thought.
Exactly. It's a different value proposition aimed at a different set of needs compared to pure cloud AI.
That makes sense. And the social media caption model, the LSW4 27DM Micro T1, is just one example, right?
Yeah.
You mentioned a suite of agents.
Oh, yes. It's definitely not the only tool in their toolkit. It's just one piece of a much broader collection of autonomous, intelligent AI agents they're developing.
All presumably built with the same philosophy. Local, specialized, efficient.
That seems to be the core principle.
Yeah.
They're building a whole set of tools tailored for specific business and community needs, going way beyond just generating captions.
Any other examples?
Sure. They mention agents for automating complex tasks, like community moderation. There's one called the LSW4 Arrow2B Moderator Copilot.
Okay, Moderator Copilot. I'm guessing that's a specialized model trained to identify, say, harmful content or spam within a community forum.
Very likely. And crucially, it could do that classification locally, maybe within the forum software itself, without having to send potentially sensitive user messages off to a remote server for analysis. Faster moderation, better privacy.
Makes sense. Any others?
They also mention one for delivering complex information called the LSW4 Slice2B Consultant.
Slice2B Consultant. Sounds like maybe something designed for question answering or pulling specific information from a local knowledge base.
That would fit the pattern. These are all likely custom-built micro-LMs, maybe slightly larger like the 2B suggests, 2 billion parameters, but still optimized for speed and local execution within their specific domain.
So it really moves away from that one giant model tries to do everything approach.
Completely. It's about having a toolbox of specialized, efficient agents you deploy for specific needs.
And underpinning all this is a commitment to transparency. You mentioned open source. That seems vital today, especially with AI, right? People want to know what's inside the box.
Absolutely critical. And yes, Web4 AI makes its models, including this micro-LM we've focused on, available as open source.
What's the benefit of that for them and for users?
Well, for the whole ecosystem, open sourcing fosters innovation. Developers can look under the hood, see how it works, even customize it or build upon it.
Builds trust too, presumably.
Huge trust factor. You can audit the code, understand the training influences to some extent. There are no hidden proprietary black boxes making decisions you don't understand.
So it gives developers a solid, transparent foundation to build their own secure, specialized applications.
Exactly. It encourages the wider community to get involved, to improve things, to build the ecosystem securely. It aligns with that whole decentralized user empowerment ethos.
Okay, let's try and wrap this up then. We've seen how this specific model, the LSW4 270M Micro T1, is this really neat piece of focused engineering. It delivers great performance for its very specific job social media captions while offering these massive benefits: user privacy, basically zero running costs, and instant local speed.
Yeah, to summarize the core takeaway, this kind of micro-LM is a really clear signal, I think. A signal that the future of AI, or at least a significant part of it, is heading towards being local, private, efficient, and open.
Delivering power right into the user's hands, literally.
Right. Making something like generating sophisticated, relevant social media text faster, safer, and way more sustainable than it ever was with the old cloud-dependent models.
It really reframes what high-performance AI even means, doesn't it? It doesn't have to be the biggest model. It needs to be the right model, precise, specialized, and able to run where the user is.
Exactly. This model, 540 million parameters in that clever dual setup, shows that smaller, focused intelligence can absolutely outperform larger, general intelligence when the task is well-defined.
Which leads us nicely to our final provocative thought for you, the listener.
Okay, here it is. If a highly specialized, relatively small model, 540 million parameters, running entirely on your phone or just in your web browser, can actually be better than a giant cloud LLM for a specific task, like crafting social media captions, then what other complex, domain-specific tasks are out there just waiting to be revolutionized by this shift, by moving away from the centralized cloud giants?
And towards personalized, serverless intelligence that runs entirely locally on your own device.
Exactly. Think beyond just captions.
Okay, like what other areas could this unlock?
Well, what about complex, real-time diagnostics? Imagine a mechanic in the field pointing their phone at an engine and getting instant AI-driven diagnostic suggestions based on sensor readings or sounds without needing a network connection.
Interesting. Or maybe personalized healthcare, like a really smart medical triage questionnaire running privately on your device before you even talk to a doctor.
Perfect example. Or highly customized education. Tutoring systems that adapt instantly to a student's learning style and provide immediate feedback, but keep all the sensitive progress data completely private on the student's own device.
The possibilities seem huge once you decouple intelligence from network dependency and privacy trade-offs.
They really are potentially limitless, this serverless local AI future. It's not science fiction. It's starting to happen now, running right there on the device in your pocket.
A fascinating shift indeed. That's all the time we have for this deep dive into the Web4 AI paradigm and the rise of the micro-LM. Thanks for joining us.
Thank you.
We'll catch you next time.